Hello everyone, in this video we're going to talk about some properties of logarithms. So if we're thinking about logarithmic functions, it says since the logarithmic function with base b is the inverse of the exponential function with base b, logarithms have properties similar to properties of exponents. So we talked about properties of exponents before, especially in Algebra 1. I have a video on that. I'll link that in the cards right now if you want to go and review those 7 or 8 properties. But for this video, we're just going to focus on 3 of them for logs. The first one is the product property. So if we have log base b of m times n, we can separate that into log base b of m plus log base b of n. So what that's similar to for exponents, that would be like if we had 3 to the 4th times 3 squared, then that would be 3 to the 4 plus 2, right? And so basically same thing there. If we have a multiplication problem, we can change that to addition. All right, for the quotient property, log base b of m divided by n would be equal to log base b of m minus log base b of n. So the property that we're talking about there for exponents would be if we had, for example, 3 to the 4th divided by 3 squared, then we would do 3 to the 4 minus 2. And once again, that video I linked in the cards earlier, you can go and check those out to refresh your exponent rules. And the power property, log base b of m raised to the n power. We can take this exponent of an n and bring it to the front of our log and multiply it. So it would be n times log base b of m. So if we're thinking about that, what we're referring to would be if we had like 3 to the 4th and then squared. So this would be 3 to the 8th power. So we use multiplication in that case. Okay. So we're going to look at about 3 examples here for these 3 properties. So one example for each of the properties that we just mentioned previously. So we're going to use log base 3 of 4 is approximately 1.262, and log base 3 of 5 is approximately 1.465. So we look at number 1, we have log base 3 of 4/5. So we can rewrite this as log base 3 of 4 division, so we're going to subtract, and log base 3 of 5. So we said log base 3 of 4 is approximately 1.262. And we're going to subtract 1.465. So now we're going to be negative 1.262 minus 1.465, and we're going to get negative 0.203 for number 1. Okay. Number 2, we have log base 3 of 20. So we might be looking at this going, hey, there's no multiplication going on there, but we can make 20. We can essentially create a multiplication problem. What are some factors of 20? Well, we're given log base 3 of 4 and log base 3 of 5, so it would be great if 4 times 5 was 20, and guess what it is, right? So we could rewrite this as log base 3 of 4 times 5, right? And so now that we didn't change the value of that, 4 times 5 is 20. Now it just allows us to say log base 3 of 4 plus log base 3 of 5. And now in the problem that was given to us, log base 3 of 4 is 1.262. Log base 3 of 5, 1.465. So 1.262 plus 1.465, and we're going to get an answer of 2.727. All right, for number 3, log base 3 of 25. Once again, we're thinking, okay, this would be the power property here, right? Well, we don't see an exponent, but could we rewrite 25 as something squared? And yes, we can. So we're going to rewrite this as log base 3 of 5 squared. So now we can bring this 2 exponent to the front and multiply. So 2 times log base 3 of 5. So log base 3 of 5 we had as 1.465. So 1.465, we're just going to multiply that by 2. And we get an answer of 2.93. Okay? And those are some properties of logarithms.